It's pretty amazing what we get for free, but that's just the tip of the iceberg. Now let's create our models, which describe the data that we'll store in our application. This is the moment you've been waiting for. It's time to write some code. Here you'll see our project and our Blat app. Inside each app we have a models.py. Note that some apps don't need models, so you're welcome to discard this file if you don't need it. But not in this app, we need it. We're going to start out simple and add complexity as we need it. We're going to have a database table of Blats. Each Blat has a unique ID, some text, and a timestamp indicating when it was added. We'll also have a field for a URL where people can use to tell us where they found this useless info. We'll also have a related table of likes. Each time somebody likes a Blat, an entry will be added to this table which references the Blat they liked. Let's open our models.py and begin adding to it. Each table in our database is a Python class that inherits from Django's models.model class. The Django convention is that our class's name should begin with a capital letter and be singular. By default, we get a unique ID, so we don't need to explicitly say we want that, though we can. This is useful if you have existing data. You can tell Django what the name of the field to use for the unique ID is. We'll add a field called text that is of type text field. If we pop over to the documentation, we see that we have a lot of field choices. If we were going to be like Twitter and limit the size of the text field, we could use a char field, which has a required argument specifying how large the data is. However, the best blather on the internet can be quite long, so let's stick with the text field. Let's add a timestamp field. We'll call it created_on, and it will default to the time the record was created. We do that by passing in the named argument auto_now_add equals true. If we want the timestamp to update when it's edited, we can also say auto_now equals true, but we don't need that. Lastly, we'll add a URL field called via to use as a reference. This field is optional, so we'll pass in the blank equals true statement. Note that on some databases, it is also necessary to specify null equals true. This will store a null value in the database if that is required. Now we need to add a second class called like. This file will have a foreign key field pointing at Blat. There are different kinds of relationships. Foreign key is simple and common. Check the docs for more info on foreign keys, many-to-many fields, and one-to-one fields. Before we move on, let's go back to our Blat model. I foresee a common task of wanting to know how many people have liked our Blat. We can do that by adding a model method. Because like has a relationship to Blat, we can get details about that relationship in either direction. When making a backwards relationship, we refer to self, model name underscore set. So we'll simply create a method called total_likes that returns self.like_set.count. That's it. Save your changes. If you were to test this now, you'd have a couple problems. One is, you wouldn't see the listed field in the admin interface, because we need to do two things to tell Django this app and its models exists. Also, we'd have to create the database structure. Let's start by telling Django about our app. In the blather folder, you'll see a settings.py file. Open this and look for the code for installed_apps. You'll see this as a list of strings. We need to add a reference to our app, so use blats in quotes. Save this and close the file. Now we have to tell Django admin interface about our models. We do this by opening admin.py in our app. This file isn't too exciting yet. The first thing we'll do is import our new model. At the top of the file, type from blats.models import blat. We can also import like, but since we have a model method to keep track of likes, I don't see a great need to manage it in the admin interface. With our Blat admin interface, we have two options. We can keep it simple and just let Django use its default options for showing this model in the admin area. We do that by adding a line like this, admin.site.register_blat. This is absolutely okay to do. However, we're going to play around with our configuration in a moment, so we'll instead create a new class that inherits from admin.modeladmin. We'll call it blatAdmin. For now, this class does nothing, so simply type pass. Then we'll add a second parameter to admin.site.register that passes in our new class. At this point, when we start the server, it will try to show our model, but it won't work because the database hasn't been updated. In order to have success, we have to create a migration and then apply it. This is an awesome feature of Django. Simply run the command python manage.py make migrations. This will create a new Python file that looks at the database structure and our models and figures out what commands are needed in order to change the database to match the new structure. In most cases, this works fine. However, it's simply a Python file. So if you are ever in a situation where you want to know what it's doing or adjust the process, you can edit it. Check the docs to learn more about migrations as your needs grow advanced. We started with no database structure. Now we need some structure. So this is about as safe as migrations get. We can apply our new migration by running python manage.py migrate. We should see a happy OK message. We're set. In the next video, we'll look at the admin interface more. But before you move on, you may want to look at our newly created migration. It's in the migrations folder of our app.